Hey, pre-calc class. So today we're going to graph the sine, cosine, and tangent functions, just like you looked at before. So in this first piece, we're just going to look at sine and cosine functions, try a couple from the practice problems, and then we'll do a tangent one. So keep in mind what the parent functions look like. We're not going to deal with any transformations really this time, except for changing the period. And we're just going to graph those basic functions. So your steps to graphing these functions are that you first need to identify the amplitude of the function. So remember, the amplitude is the distance from the center of the function to the top, or the center to the bottom. So if we have a curve like that from here to here is the amplitude, or from here to here is the amplitude. It should be the exact same distance because it's from the center to the midline or the middle of that graph to the top, and the middle of that graph to the bottom. So it should be the exact same amount of space. The second thing we're going to identify is the period of the function. So we said with sine and cosine functions before, the parent function anyway, the period is always 2 pi. So that means that from 0 to 2 pi, that's how long it takes for the graph to start repeating itself. It doesn't have to be 2 pi spaces, and so we'll look at adjusting that, meaning that maybe our graph gets closer together, maybe our graph gets extended further, something like that. So that's what the period is going to do, and we have to figure out where it should start and where it should stop. We're going to mark 4 values, so we're going to cut the period into quarters, mark those 4 values on our x-axis, and then plot our curve. Okay, and so these functions follow the same transformation rules that we've been talking about forever and ever and ever in this class. And two sort of ways to look at it. So in particular, the sine function, this could be replaced with any of those trig functions. A is the number in the very beginning. And here I used x minus h plus k because that's where you're used to. But a lot of times you'll see with trig functions, it's x minus c and plus d. So think of it like you do with your quadratics, right? Just like that. And we also talked about having the b value factored out as well. So similar, all those things are the same. Today we're not going to worry about transformations left and right or up and down. We're just going to stick with a sine b for our intents and purposes. So a is something that represents your amplitude. And remember, if it's positive or negative, that number in front also tells us whether or not the graph has been reflected. So it represents the amplitude and the reflection. And b represents the horizontal dilation. So again, how scrunched or spread out that graph is. And that's what helps us find the period. So 2 things to really write down maybe at the very top of your paper. To find the period, you're going to do 2 pi divided by b. So we're taking the standard period and dividing it by whatever number is in front of x. All right? So if our equation is y equals 3 sine of 5x, all right, then 5 is b, and a is 3. Well, that tells me that my period would be 2 pi over 5. So 2/5 of pi is 1 full cycle of this graph. And then your amplitude is the absolute value of a. And so I say absolute value because we're talking about a distance, right? And distance should always be positive. So if we look at the a value, it's 3. That means my amplitude is 3. If this had said -3, that would just tell me, okay, instead of the regular sine function, which starts in the center and heads up, this function would start in the center but head down first. It would be reflected over the x-axis, all right? So that's all we're going to deal with today is period and amplitude. So let's go try a couple practice ones and see what we can do with your practice questions. So the first two are the most basic ones. But then let's try maybe -2 sine x. All right. So the first thing that we see is it wants me to identify the amplitude and the period. Well, the amplitude is the absolute value of A, and that's A, so it's in front. So 2. So I'm going to draw in some boundaries at +2 and -2. Those are sort of like horizontal asymptotes, and they're not necessarily part of the graph, but they're just keeping my function from extending beyond that, keeping me in check. And then 2 pi over b, well, if we just see x, there's like a 1 that would be in front of it, okay? So the period is 2 pi over 1, or 2 pi. What that tells me is that my graph begins at 0, ends at 2 pi, and then, like I said, I want to label my x-axis in quarters, because at each quarter, something else is going to happen in the change of direction here. So 2 pi, if I cut that in half, so I have four boxes here, you can see. If I cut it in half, that's 1 pi. If I cut 1 pi in half, that's pi over 2, or half pi. And if I cut that in half, the distance between pi and 2 pi in half, I get 3 pi over 2. Right? Let's see if I can write that a little smaller. So just like your unit circle, and that can help you out if you're trying to find these values. Pi over 2, pi, 3 pi over 2, 2 pi, right? Those would be the 4 quadrant values all the way around. Pi over 2, pi, 3 pi over 2, 2 pi. We know they're all evenly spaced, right? So when I go to graph this here, we know it's the sine function, and so if you remember from your parent functions, does sine start in the middle of the graph, or does the sine start at the top of the graph, top or bottom of the amplitude? Well, in our case, it's sine. Sine always starts in the center. Cosine is the one that's going to hit the top or the bottom of your amplitude. So for sine graph, I'm going to make my first point in the center. Okay, and then I know that it's going to end in the same place at 2 pi, and because if it were positive sine, we would go up first to the top of our amplitude and make our point up here. But this is negative sine, so that tells me it's been reflected. So instead of me going up to the top of my amplitude, I'm going to use that value to go to the bottom of my amplitude. That's why I have those barriers there. And then the next tick mark on my graph, I went from the middle to the bottom. Now I'm going to go back to the middle. And then at the next tick mark, the next mark on my x-axis, I'm going to go to the top of my amplitude. And then finally back to 2 pi, back to the middle. And connect my curve, right? And that would continue in both directions if I wanted to do that. So the reason I'm making those 4 marks is because at each mark, I'm making a piece of my sine function or cosine function. Sine would start in the middle. If it were positive, it would go up to the top of the amplitude first. Negative, it goes down first. Then to the middle, top, back to the middle. All right. Let's look at another one. Let's try maybe number 9 together. I'll keep with sine just so we get that idea down. So let's do positive. We have y equals 3 sine of 2x. So again, let's identify a couple things. Amplitude is the a value, so amplitude would be 3. And the period is 2 pi over b, or 2 pi over 2. Well, if I divide that, I get 1 pi. So here, my period is going to be 1 pi, a distance of 1 pi, and the amplitude is 3. So up at 3 and down at -3, I have my amplitude. And then I have cut my graph into 4 equal parts. It's already done for me. The first being 0 and the last being positive pi, because that's what my period is this time. So one full sine curve is going to fit between 0 and pi. Well, if I go and label the rest of these values, halfway between 0 and pi would be pi over 2. From 0 to pi over 2, if I cut that in half, it's pi over 4. And from pi over 2 to 1 pi, well, that would be, so we have, think of it as 1/4, 1/2 is 2/4, and this would be 3/4, and 1 pi is 4/4. So this is 3 pi over 4, all right? The hardest part usually is labeling your x-axis, so don't get too hung up on that. See if you can graph it without doing that, if that's where you're getting stuck. So now that we have everything labeled, we know it's a positive a value, so the sign is going to go trend up. Sine always starts in the middle, so I'm starting at the origin. At the first tick mark, I'm going to go up because it's positive sign to the top of my amplitude. Then I'm going to go to the middle. Then I'm going to go down to the bottom of my amplitude. And then back to the middle and connect your sine curve. Right? So as long as you've drawn one full period, that's all we really need to see. Okay? And then let's do one of the cosines just to see the difference here. Oh, why don't we try this fraction one? I know you guys won't like that. So here the amplitude, there's nothing in front of cosine, so that's 1. So here I have my amplitude bars drawn in at 1. And then the period is going to be 2 pi divided by 2/3. So when we divide by a fraction, that's the same as multiplying by the reciprocal. So it'd be 2 pi times 3/2, or 6 pi over 2, or 3 pi. So that's a really big period. 3 pi is much bigger than the normal 2 pi, right? So this is going to be one of those functions that's a little more spread out. So I'm going to go for still 4 tick marks. And that fourth one I'm going to label as 3 pi. The first one is obviously 0. Halfway between 3 pi and 0 is 1.5 pi, or you could do 3 pi over 2 if you'd like. And then, let me write that a little better. And then you could label in between, so between 1.5 and 0 is going to be 0.75, or 3 pi over 4, right? And between 1.5 and 3 is 1.5 plus 0.75, right? Or that would give me, what, 2.25 pi, which would be 7 pi over 4. All right, so I've labeled my axes here, and did I do that right? 6 pi over 4. Well, we'll come back to that. But anyway, labeled my axes, and then for cosine, the difference between the sine and the cosine graph are that the, sorry, I knew I did this wrong. 9 pi over 4. That's bothering me. Why can't I write? There we go. The difference between the sine and the cosine graph is that cosine starts at the top of your amplitude if it's positive and goes down. So when I draw a cosine graph, I'm going to start when x is 0 at positive 1. At the next tick mark, we're just going to follow that curve, so it goes down to the middle, and then the next tick mark, it goes all the way down to the bottom of the amplitude. The next tick mark, it goes up to the middle again, and then at 3 pi, we're back to the top. So you can see, and that wasn't actually my best curve there. There we go. So you can see you're getting this, the cosine curve, and if we continued that in that same fashion, it would start to resemble the sine curve just shifted over, right? So I want you to pause here, try the sine and the cosine graphs, and then come back for a quick video on graphing the tangent.